Today we will talk about climate change and, of course, about the assessing the vulnerability. That is your first step in preparing the adaptation strategies. I really like this picture as a starter. It's showing like us being so small compared to the natural ecosystems, and yet we leave such a huge footprint. So my question is, do we know, or maybe do we even want to know, where are we going? Today, after this lecture, it is important for me that you understand and that you are able to explain to your partners or stakeholders why is it so urgent to focus on adaptation? Why do we have to do it? So for the beginning, I will talk about climate change itself, just shortly, and something about emissions and mitigations, global risks, but mainly about risk and vulnerability assessment. That is the necessary and very important first step in the process of adaptation planning. Probably your background knowledge is pretty much variable, not the same for everyone, but I hope that from this lecture you will gain something, and that it will be something interesting and something useful for each of you. So let's start. For the beginning, it's really basic, but what is climate change? For a very long time, there was the balance between incoming solar energy and outgoing Earth energy. This is named the era of Holocene, where it enabled us the life on Earth like we know it. So the incoming solar energy is shortwave radiation. It's different than the outgoing energy of Earth, that is long wave radiation. This is very important thing because characteristic of incoming and outgoing energies are not the same. And this is why the things are happening like they are. So, question for you, or for to think about, what would be the temperature on the Earth without the atmosphere? Yeah, maybe you know it, maybe not. The Earth would be frozen. So without the atmosphere, the life on Earth wouldn't be possible. And greenhouse gases, those are water vapor, CO2, nitrogen oxide, methane. They represent less than 1% of the atmosphere, but because of their characteristics, they absorb around 90% of Earth's outgoing energy. And then they emit this energy in all directions, so also back to the Earth. And this is the way how the energy comes back, and the temperature on the Earth is around 15 degrees. So this allows us our living on the Earth. But today, things are already different. The system is imbalanced. So due to the increased concentration of greenhouse gases, more energy is coming back to the Earth. Fortunately, we are very lucky for now. Oceans accumulate the majority of the energy excess, as you can see. This can be a huge problem later on, but for now, it's a very good thing for us that the atmosphere is only accumulating 1% of the excess energy. But anyway, the atmosphere is getting warmer even with this 1%, and we call this global warming. And mainly we have three problems. The first one, emissions of greenhouse gases are very high. You can see here the timeline of the greenhouse gases emissions of CO2. And even if we have a decrease, like there was a huge decrease during the COVID pandemic, but after one decrease, there is always a rebound. So we are not really good in keeping emissions low. Our second problem is that the CO2 and other greenhouse gases stays really long time in the atmosphere. So after 100 years, there's still 1/3 of the original concentration, and after 1,000 years, there is around 1/5 of the original concentration. So even if we stop the emissions, the concentration will really slowly decrease. And then there is the third problem. In the climate system, there are many positive feedbacks. These positive feedbacks are positive only by their name, and they're not positive for the climate, for us. They are like self-amplifying responses. So if we have one initial change, then there are systems that are just amplifying and amplifying the response, and we cannot stop the change anymore. But we can talk more about all this in the next lecture, when we will specify also on adaptation and on already seen climate changes. So when we talk about cities have an outsized contribution to greenhouse gas emissions. Although covering less than 3% of the world's surface, cities house over like half of world's population, consume around 2/3 of the world's energy, and for us, the most important thing, account for more than 70% of CO2 emissions. And the primary sources are transportation, energy production, and buildings. What we said before is that with increasing CO2 emissions and other greenhouse gases, there is global warming going on. And we see here observed warming since the pre-industrial era. So the pre-industrial era is the name for the period of 1850s to 1900. And we usually look the deviation from this era, from pre-industrial era. And we can see here global surface temperature changes. This black line, these are observations. And when we are modeling this line, we can only reproduce this kind of data if we use combined human and natural causes. And we can see here that because of the natural causes, the temperature is not increasing, almost none. And due to greenhouse gases, there is a huge increase of the temperature. But there are also aerosols that these are usually the pollutions in the atmosphere, and they are causing the cooling of the atmosphere. So this is also human source, but it's helping us to reduce the global warming. And when we talk about global warming, usually you will hear about the global temperature increase as the first information. But this is only the average for the whole world. And you cannot really imagine what it will mean for, let's say, your country or your city. So maybe question for yourself. You can just think about it, or you can say it loud if you want. If you know, what is the 30-year average annual air temperature in your city or in your region? We always talk about at least 30-year averages in the climatology. Why? Because then the natural year-to-year variability is already averaged, and you can really talk about climate. And as you can see here on the map, the Arctic has warmed nearly 4 times faster than the rest of the world in the last 50 years. So even though we have one number for the global temperature increase, climate change is not uniform and it's not proportional to the level of the global warming. So you have to be really careful to see your local scale, to see what will happen in Europe, or more precisely in your city. And as the reference, you have to know your current climate conditions, because in the term of climate change, we always talk about the deviation from recent period or from previous period. So you need your reference. What is your annual air temperature? And the other things are distributions. This is more complicated thing, but when you talk about the average temperature, there is the distribution of all temperatures around this average or median. And when the average moves to the higher value, then also, of course, the distribution moves. And it means you have much more hot days than you had before. And this is true even if the distribution is not changing. But what we notice with the climate change is that also distributions are changing. So it's getting lower and broader, which will bring even more hot days or hot extremes to the whole world. And now we are at the point when I can really emphasize why the adaptation is so important, or why it is really urgent for you to do something in your cities. We saw an increase in greenhouse gas emissions, and we know that there is, or at least should be, mitigation going on, so reducing of our emissions. And according to Paris Agreement, countries try, or at least should try, to limit the warming, so the global average, below 1.5 degrees of deviation above pre-industrial era. But with our current targets and pledges, we are going somewhere here to the end of the century, so to much higher values. There is already a target gap. And with our current actions, we are aiming even higher. So we have even higher implementation gap. We should be on the line going down to 1.5, but we are somewhere here going to 2.6 or 2.9 degrees of warming. So climate change is already happening. With global warming, global warming is only the temperature increase, but climate change is everything else connected with the temperature increase. So we are headed in the even higher changes, and there is no other way to alleviate these changes than to be very, very well prepared, to prepare adaptation strategies. One more example. Maybe you saw this graph in previous weekend, so on November 17th. It happened the first time ever that world temporarily breached 2 degrees of warming. This is really a huge, huge alarm for the humanity. Of course, this is not a long-term average, as we were talking before about 1.5 degrees of increase. We didn't reach 1.5 on the long term. This is just the current situation. But still, this is the first time this threshold has been crossed. And this year, global temperatures set records in each of July, August, September, October. And the El Nino cycle is just beginning. So this just sadly represents a small taste of what is to come. So it is really urgent to prepare better, to prepare your vulnerability assessments, your risk assessments, that will be the base for your adaptation strategy. So we will talk about risks and impacts. Risk is the probability of something happening, and the impact is the outcome of climate change on a sector or system. And why we don't want the world beyond 1.5 degrees of warming? Because it will lead us to a highly uncertain world that we don't know much about. Then there can be tipping points, and when they are overcrossed, we don't know what will happen with some ecosystems. So in the IPCC reports, I don't know if you already know the IPCC, it is the Intergovernmental Panel for Climate Change. And their reports, now you have the 6th report, AR6. They are like, we can say this is the Bible of climate change. So it can be really a good base of everything that you are doing or researching. There are thousands of pages in this report, so maybe just take a look of what is the most important for you. So in their reports, impacts and risks for some various systems are represented in diagrams like this. So this is the color scale of the intensity of the risk, with purple being the highest. And on the graph, you have the rate of global warming. So we are somewhere here in the gray, with around 1 degrees of global warming already reached. We are a bit above 1 degrees. And you can see what are the risks when we are going to the higher temperatures. For example, very, very high risks for warm water corals. And of course, maybe this is not important for us, for Europe. So the question is, what do you see as the key risk for Europe? Probably you have something in mind, especially with extreme events of this year, with extreme floods, extreme heat waves, and now yesterday even extreme snowstorms in Europe. So I think there are plenty of things we can think about. And this is the IPCC diagram for the Europe. We have 4 key risks that we can talk about. So again, here is the global surface air temperature change relative to the pre-industrial era. We are somewhere here in the gray area. And these dots near the each color bar, they mean the confidence. So how confident are the scientific reports or research on this topic? So with 3 dots, you can be really certain that this is going on, and with 1 dot, there is a lot of uncertainties. And we can see at the first risk is about heat stress. The second one is crop production loss. Then we have water scarcity and flooding. So these are the main 4 risks as they are described in the IPCC report. So how do you use this graph? You can see, if the temperature will increase to 2 degrees, what will be the main risk, and you can see the purple color here at the flooding, one of the impacts of flooding on one sector, or the second one, water scarcity in Southern Europe. So just to have a general overview of what is going on. So to conduct the vulnerability assessment, it is of course necessary to understand how future climate conditions might be different in terms not only of temperature, but also humidity, precipitation, sea level, so whatever is important for your city. And we start, of course, with the observation of past trends to see what is going on in our climate and what are the changes that we can already talk about. And the other thing is, since there is no way to know the future precisely, of course, the assessment uses scenarios. So based on the best available science, the scenarios represent plausible future conditions. Maybe you will be, if you didn't work with scenarios before, you can be a bit confused at the beginning, because now there are results in the form of two kind of scenarios. From the previous IPCC report, there are RCP scenarios. So this is the name, or here you have RCP scenarios. And from the last IPCC report, we have SSP scenarios. They are similar to each other, but not the same. So just a quick explanation, and we can also discuss scenarios even more in the next two lectures. So just to know what we are talking about, RCP means representative concentration pathway, and the number near to the RCP, so 2.6 or 4.5 or 8.5, it means how the energy balance that we talked about in the beginning, so how the energy balance of the Earth will be changed to the end of the century. If we have the RCP 2.6, it means there will be 2.6 watts per square meter more in the imbalance of Earth's energy. So the higher the number, the worse is the situation. So RCP 2.6 is very optimistic scenario. If we try to mitigate climate change, to reduce our emissions, then 4.5 is like a middle way, and 8.5 is a very pessimistic scenario if we don't reduce greenhouse gas emissions and we go out of all boundaries with climate change. And then in the latest IPCC report, we have SSP scenarios. These are shared socioeconomic pathways. And the first number is 1 to 5, showing which pathway the humanity will take. We will try to do our best with the mitigation of climate change and establishing equality in the world and so on. This is number 1, or number 5 is the worst one. But again, there are 2 more numbers in this name, which are the same as in RCP scenarios. So they are kind of comparable. You can see here lines for, let's say, RCP 2.6 is this one, and then with the whole line you have SSP 1 2.6. So what we can say, this is an optimistic way of climate change, this is a middle way, and this is a pessimistic way. And for surface air temperature, you have a really minor increase of temperature in the optimistic scenario, and let's say very, very high temperature change on the pessimistic scenario. And all these numbers for the temperature change and for the other variables that are following the temperature change, we have the middle value, the median or the average, and then we have a span of values, because scenarios are then used in climate models, and we use a lot of climate models on global scale, like 50 models can be used, and then you get a span of the results, so you don't have only one number, but the variability, and you can be somewhere in this area with your temperature change. Here, this is just like a vocabulary. I put it here for you, but we will not take a look of everything, maybe just the most important terms to continue with is one is hazard. So the potential occurrence of climate related physical event that may cause loss of life, injury, health impacts, damages, losses. And we will of course talk about vulnerability. So this is the degree of to which a system is susceptible to or unable to cope with adverse effects of climate change, including, of course, climate variability and extremes. And we will also talk about adaptive responses to current climate change, which are about reducing climate risks and vulnerability. So maybe we can just take a look of the basics of climate vulnerability. So there are many various methods, but at the end they are very similar to each other. How to assess climate vulnerability and how to assess all risks. So according to IPCC, the climate vulnerability is determined by a combination of exposure, sensitivity, and adaptive capacity. So exposure. We said we talk about climate impacts and climate hazards. So it's important to know here what is the frequency or severity of climate hazards. And because we are talking about exposure, usually here we talk about some areas impacted by climate hazards. In sensitivity, we try to describe household and community characteristics, quality of housing, quality of some systems, functionality, access to services, and so on. So this is our sensitivity. And in adaptive capacity, we are trying to describe how good can we be in adaptation process. So what is our information, skills, communication, institutional and social capital, and so on. So the climate risk and vulnerability assessment that you will perform is the first critical step towards climate adaptation, because it will help your city to understand your current and future climate hazards. Without this, you really can't have a very good adaptation strategy. So it requires understanding the current and projected climate hazards, the exposed and vulnerable sectors of the city or of the broader area, and the scale of adaptation achieved. So for like the information, 4 out of 5 cities report facing significant climate hazards such as extreme heat, heavy rainfall, drought, and flooding. So these are really the main ones. And almost 1 in 3 cities are facing significant climate hazards that threaten at least 70% of their population. So this percentage is really high, and it's important to do something. And with the climate change, sometimes it's not really that averages are changing so much. We saw that the temperature is, of course, increasing, but for precipitation, it's not necessary that there is a change amount of rainfall, but the patterns of temperature, precipitation, and sea level that were used to design your buildings and your infrastructure, these patterns are shifting to new ones, and that will affect both the built environment and people. So if we just left them vulnerable, climate change poses significant threats to cities' economy, quality of life, public health, and even safety. So it's really much better to plan ahead, to be proactive, instead of trying to react after. So to just try um, to do something when damage is already there. So from European Environmental Agency, these are some examples. Of course, they are not exhaustive and they are not really relevant for all cities, but we can start with this. So here you have the main hazards: heat, floods, water scarcity, wildfires, and storms. And you will do with the very same ones for your city. And they will impact living, working, and moving. For example, if we just take a look at, let's say, water scarcity, for living, it can cause discomfort, health, and safety risks. For working, it can reduce productivity. It can cause power and water failures. And for moving, let's say, it can cause shipping constraints. So for each of the hazards, you will think about the impacts to your city. For all sectors, of course, these are just examples of living, working, and moving, but you have many sectors that you have to think about. I also want to show you two results of the research in 2018. This was the research in more than 500 cities with more than 500 million inhabitants. And here, for example, they assessed top social risks due to climate change on short-term, medium-term, or long-term scale. And we can see that the first or the most important ones were increased risks to already vulnerable population, demand for public services, diseases. And it's pretty much the same also for medium or long-term scale. And this is the other result where they try to identify public services that are most vulnerable to climate-related risks. And public health is the first one, then followed by residential, water supply, transport, and so on. So just to see what is the first outlook. And in your project, risk and vulnerability assessment will kind of follow this urban adaptation support tool. So mainly you will follow these steps. You will use indicator framework that is already prepared by your leading partner. You have a very nice tutorial how to do it, and at the end we will also take a look of some sources that will be used. So it is not your aim to derive just a singular number or score for any given sector, but to provide a framework that will support your team in exploring interrelated local risks and vulnerability context. So you will start with recognizing past and present climate impacts in combination with understanding climate projections and future impacts. You have to be careful because new hazards and impacts may also occur. So even if you maybe know your hazards in this period, you still have to be careful about things that may occur in the future, and you can analyze it using climate scenarios. And especially with trends and climate scenarios, you have to be careful with interpreting the information. So before we just shortly talk about the climate scenarios, you have to be careful which scenarios you will use, how you will describe uncertainties, and which period you will take. And further on, you will identify your vulnerable urban sectors. We will talk now in the next few slides about combination and interconnection interconnection in sectors. And then you will conduct your final risk and vulnerability assessment. You will also work with stakeholders, so you will have workshops or meetings with city stakeholders. You will have to explain your approach, the required data or the data that you already used. And of course, it is important to discuss your selected indicators and their relevance, ranking methods, with your stakeholders, and they can help you identify some missing data or missing indicators. Further on, it's important to understand the role of surrounding areas, so they can impact on the city, of course. If there is a climate impact in area that is providing some services to the city, you will of course notice it and you have to take it into account. And also the other way around. So if there will be a disrupted access to urban jobs, resources, and so on, it is important to, again, take it into account in the vulnerability assessment. So then you will, at the end, identify main adaptation concerns and define the objectives. This is how your indicator framework tool looks like in the Excel. You probably already checked it out. So I will not talk about it, but just to emphasize that you have here hazard indicators, exposure indicators, vulnerability indicators, and response and adaptive capacities indicators. So it is important to address all of them and to think which combination is the most important one for you. So it will not be necessary that you use all vulnerability indicators if you have only like one hazard that you are talking about, but your vulnerability and response indicators have to be the right one for your exposure. And you will use then the standardization or like a color scale to show for each of sectors or for each of impacts what is your level of exposure or vulnerability. So it is very essential for you to look at all indicators simultaneously, that you will understand underlying complexity and that you will have an overview of everything that you have to take into account. And we will go through one example or even more. So when you think of your city, you will research which climate hazard is the most important for you. The suggested ones in your tool are heat, floods, water scarcity, landslides, wildfires, and extreme weather events. So these are really all the main hazards that are important for Europe. And as I said, we already know all about the global climate that is shifting towards warmer conditions. But there is, of course, additional work needed to translate how those changes will present at your local level. So for each of them, you have to assess probability and severity. So how likely is the impact to occur, and how serious would the consequences be for your city or for one of the sectors in the city. You will, of course, use climatology data like rainfall intensity, temperatures, and so on. You will need hazard maps like flood maps, and you will need also sector maps that are like more social ones according the infrastructure and so on. And then, as I said, you will start with historical trends and events. So you probably know how each hazard affected your city in the past, or you can ask someone, or you can see meteorological trends. And with future projections, you have to choose climate scenarios. So you can use all scenarios. You will have much more work to do, but you will get a broader picture of what can happen in the future. Or you can just say, okay, we will take a look what will happen with this degree of warming in numbers of global warming. Or you can use RCP scenarios or SSP scenarios. Probably for the cities, when you are planning way ahead, it is good practice to evaluate the worst case scenarios. So the high emission scenarios, like we said, RCP 8.5 or SSP 5, 8.5 or something like this. Because in this way you will understand the most extreme potential effects in your city. And the other thing is that you have to choose your time horizon. So when we are talking about future climate effects, you can take a look of the middle era around 2050 or to the end of the century. But probably if you will have some city term plans, it will be the middle period. So also in the proposed links, there are some variables that are based on the RCP 8.5 scenario and the middle time horizon, as you will see further on. And in impact assessment, you have to really think which sectors you will choose and what are other factors that can be important for you. And you have many, many variables proposed in your tool for assessment. So here can you see one very talkative bubble diagram. If you choose heat, for example, there are climate hazards that are connected to heat, like heat stress, increased evapotranspirations. These are water losses, heat waves, urban heat island, and so on. Then you think about social impacts, like reduced work productivity due to heat stress or heat stroke due to heat wave. Then you have some natural impacts like biodiversity loss due to extreme temperature at night, And you have some economic impacts, like, let's say, yield loss due to heat stress. So for each of the climate hazards, you think of social, natural, and economic impacts. And then when we talk about the time horizon, maybe it is good to think about the difference in some climate impacts, because some of them are very rapid, like flood of storm, and you have to be prepared in the way that you can react to this kind of event very quickly. And the other one are slow onset, like chronic or something. So you will, of course, act differently if you will talk about rapid or slow impact. And you have to take this into account when you are thinking about changes that are going on. As I said, it is really essential to look at all indicators simultaneously, because the system, especially in the city, is very complex. Here is just the representation of climate hazard impacts that can impact various sectors. So you can see like a confusion here with all the sectors. And of course, sectors, they are interdependent with one another. So this is another thing you have to take into account. How we can see this in special examples? Like if maybe you have one climate hazard and this one impacts multiple sectors, like extreme precipitation. Because of water supply contamination, it impacts your water sector. Or because of the crop failure, it impacts your food sector. So these sectors then have, because of the climate impacts, they have some consequences, let's say on public health or on environmental contamination or something else. And probably you will always end with some economic consequences that actually you want to reduce. So basically the principle of adaptation is that you want to diminish economic consequences and public health and safety consequences. So this is actually your main aim to do. And here you have another example, a different kind. So you can take a look of transportation. You research which are all the climate impacts that will affect your sector, like extreme precipitation, extreme heat, and sea level rise, can all impact the transportation. And then further on, transportation can impact other sectors, like this disruption to maintenance and fuel delivery services. It will impact the energy sector. And again, it will have public health consequences and at the end, economic consequences. And the same structure is, let's say, for energy. You can have extreme precipitation, extreme heat, and drought that will impact your energy sector. Again, energy sector will impact other sectors and lead to economic consequences. So these are just examples how to think about the problem. And the last one is, if you take one sector like food and you go back to see which are sectors that are impacting food and what are the climate impacts on these sectors. And again, you have to describe at the end public health and economic consequences. And here you can see an example. This is a real example for Kuala Lumpur. you have a bubble diagram. They thought about drought and all the consequences. So you have natural, social, and economic impacts. With higher bubbles, it is highly prioritized impact, and with smaller, it is not so important. And you can use bubble diagrams like this in the stakeholder discussion. So you can review and validate uh, this kind of bubble diagram with a range of city stakeholders. You can make sure that all relevant impacts are captured. You can ask stakeholders to select the most important ones, and so on. So it is just a good way to communicate the impact. And when you will be assessing the adaptive capacity, you really have to take into account many many factors: socioeconomic, governmental, physical, environmental, and all services that can be in help to adapt. But you also have these kind of indicators gathered in your tool for the vulnerability assessment. So at the end, you will probably try to describe risks using hazards, exposure, vulnerability, and impacts. So this is like an example for energy sector. You think about the hazards, let's say more extreme precipitation, increase in yearly average precipitation, increased surface runoff, lightning. And then you think about exposure. So what are the sectors, things, people that are exposed? What is your vulnerability? Like maybe you have low elevation level, exposed electricity system, and so on. What is your adaptive capacity? You can increase infiltration, and so on. These are the main impacts. And then you say, okay, the main risks are the disruption to service delivery, increasing costs of energy. So you can have many indicators. Here you can see the example for the same variable. These are all about precipitation, so all about rainfall. You can use many variables to describe one hazard. Or you can try with climate risk statements, like in this case. So you assess likelihood and consequence of, let's say, increased precipitation that damage water supply infrastructure, and this is high risk for you. Or you even take into account vulnerable areas. It is not always necessary that the whole city will be vulnerable, and which are urban actors and which are low, medium, and high adaptive capacities to the system. So now I have some examples from some already prepared risk and vulnerability assessment of some cities. You can also take a look of all these vulnerability assessment. I have the collection of them, and you can get it. So this is, let's say, for city of Somersville, how they assess the most vulnerable assets, really specific for 3 hazards, and they were talking about streets, paths, fire stations, and so on. So they were really specific in these assets. And here, let's say for the city of Ottawa, I just took out this example of precipitation impacts. So they said, oh, what is the city vulnerability and community vulnerability, city risk and community risk? And these are their impacts. For example, they have high city vulnerability to unmanageable volumes of stormwater on landfill sites. and they have, let's say, low community risk of flooding of parks, sports fields, and so on. So when you have a final table, then you really get an overview of everything together. Then this is, let's say, the example of for city of Bloomington. They were also very specific when they were defining vulnerable population. You can see here various groups of people, children, seniors, disabled, and so on. And here are the impacts. So extreme heat, flooding, air quality, and so on. That are these are climate risks, and they also have economic climate risk like crop yield impacts, energy costs, and they really calculated very specifically how many people will be at risk or will be vulnerable due to these risks. This is maybe even too specific. I think you can not really be so exact with these numbers. And then there is a good example of the Cambridge. So they were really focused on infrastructure because they said that the ability of city to function is tied to its infrastructure. So they studied 6 major systems. They used, of course, climate scenarios, and they conducted the vulnerability and risk assessment for each system. Of course, with the aim to determine the most at-risk assets. And here they are again very specific, like some hospitals, centers, cities, and so on. And their major risks or the major hazards were heat and flood. And as you can see, they were studying 2 periods around 2030s and around 2070s. Okay, and I really like this presentation of City of Rochester. So when they already identify their hazards, they presented them very very nicely for the common public, to develop a clear key message to the city itself. And for infrastructure, natural resources, and socioeconomic resources, they assessed not only vulnerabilities, but also their strengths and opportunities. So I think this is also very important to identify also your relative strengths of current conditions, so that then later on in your following step, you can really design meaningful plans and impactful measures for strengthening the resilience of your city. And of course, altogether, as I said, to develop a clear key message for all your citizens or all your stakeholders on various levels. Okay, so these are the main sources that you will use. So they are gathered, prepared by your leading partner and gathered in your tool for risk and vulnerability assessment. And we will take a look of some of them when I finish this presentation. And I only want to show you some further links. So these are based on Copernicus Climate Database Store. I don't know if you know the Copernicus database. There are really many data. So you are encouraged to of course, add some indicators that are relevant to your context and that they are currently not included in the tool. Maybe for some of them, it is a bit more difficult to download or to find the specific data for your place, or it is not so easy available sometimes, but we can also help you with this if you will have some questions or problems. And some of them are prepared especially for cities, like this air temperature in Ljubljana. It is very very good resolution of 100 meters, but this kind of data are not prepared for all cities. So you have to check if there is this kind of source available for your city. For some of them, you have to be really careful when reading the instruction, of course, and to see what the term means. Like you can have very important variables according to floods, like 100-year flooding area or 100-year storms. That means this is a storm or a flood area that have a 100-year recurrence interval. So it will happen once in 100 years. But you have to be careful with it, because with climate change, also these recurrence intervals can start to change really quickly. And of course, you cannot be sure that it will happen only once in 100 years. So, for example, in Ljubljana, we had this 100-year flooding or 100-year amount of precipitation that fall in one day. That happened in October or at the end of September 2 years ago. But then it happened again the next year, so last year. Even though we could expect it just once in 100 years, it happened 2 times in a row. So still be prepared for this kind of events. So I would like to finish this part of presentation with some sources of European Environment Agency, and with this picture, because I like it really much. It's showing the difference between equality and equity. And I want to emphasize that vulnerability is really not evenly distributed among the neighborhoods or households. So it's really important that you think about all possible vulnerable communities. And I think you have a really good tool prepared to identify and analyze and assess your vulnerabilities and potential risks in your city. And then you will be able to prepare a strategy or plan to minimize exposure to hazards, reduce vulnerability, and increase your resilience. So now I will stop sharing this presentation, and I will open some of the sources that you will use for your vulnerability assessment. So let me just change this sharing to the other one. Okay, we are still here. Just a moment. Okay, I hope you see now one of your sources.
Yeah, it's visible.
Okay, great. So I think this is one of the sources that you will use a lot. It is mentioned, of course, in your tool. It is European Climate Risk Typology, prepared also during one of the European projects. So here you can choose your region, not really city, but the region. Let's say Maribor will probably choose this region, and you have here very nicely organized variables or indicators for hazard, for exposure, for sensitivity, and for adaptive capacity. So as they are all gathered here, I think many of the partners will use this page. But I just want to for you to be also careful about some things. So here you have many climate hazards, like projections of temperature change or precipitation change, also wildfire hazards, coastal hazards, drought hazards, and so on. So you will just choose whatever is important for your city. And let's say that you will talk about the heat. You have here projected change in maximum temperature for this area. And here you have also the scenario. So this is a very good thing that you know which scenario it is. It is RCP 8.5. So this is the scenario that is a pessimistic one that will show the major change. And here you have the value of the change. You have to be careful about the period, as I said. So if you click on it, you also get the additional information, and here you can read about the period. So this change is for the middle time horizon, and the value means the deviation from the period 1981 to 2010. So you will usually now find the deviations according to this reference period. So the global average change is in degrees Celsius according to the pre-industrial era, but all these projections that you will find, it will be according to this reference period, or you have to check if it is something different in the data. But what I'm missing, so we have the scenario, we have the period, but there is still one thing I would like to see as a climatologist. I will show you the case for Slovenia. So this is, of course, the European base. And if you don't have another source of data, it is a good one to use. But if you have some national sources, I would really strongly suggest to you that you use your national data. They will be more specific or more adapted to your area. For example, in Slovenia, our meteorological office prepared climate projections that are basing on these European regional models, but they are improved for our situation, for our climate. So if I show you the case of Maribor, or northeastern part of Slovenia, this is from our meteorological office. Here we have temperature. This means maximum temperature. And these are scenarios that I talked about. So for the middle period, the number that we saw in the European panel is pretty much the same. It is in this red line. We saw the number 1.9, and also here, this is pretty much the same value, a bit lower here in the main red line. But this presentation also have the broad range of values that tells us how certain can we be about this value. So actually, the change that we are expecting, according to this pessimistic scenario in 1950s, it can be from, let's say, 1.2 to 3 degrees. So I would like that you also take into account some uncertainties or some ranges of changes. So not to only talk about one number, but the range of the values that we can expect. And then you have some other sources that I think they are not as problematic as climate, because in climate data you have to be careful about, as you said, scenarios, period, and uncertainties. But with exposure, let's say you have population in settlements exposed to fluvial flooding, this is not a problematic value. You can just take it. Or in sensitivity, you have, let's say, population change in older people or something like this. Here you will probably have problem that many of these variables are not available for your area, so you will have to find your national sources or for this adaptive capacity. I think that for sensitivity and adaptive capacity, you only have to be careful that you use the ones that are really in connection with the exposure or hazard that you are talking about, because not all of them are connected. So here you have also a good source in Climate Adapt, urban adaptation map viewer. Again, heat, flooding, water scarcity, and so on. And you can see the data for some cities or colored data for some areas. Then this one is about more about the presentation. So this resilient dashboard is actually used in your tool to present the data this way. And you will use Eurostat. This is also not a problem, because they are getting their data from national statistics offices. So it's just the data that you take then for your analysis, or you can contact your national statistical office, and they probably have even more data available, or even more detailed data for you. Then you have some sources from European Environmental Agency. Here again, you have to be careful that these are not really detailed data for each city. So it will be just mainly it will be a general assessment of the situation, but it's better than nothing. This is also from Eurostat, a very good source of economical variables, social variables, and indicators. So, as I said, not problematic to use. You can find really many information here. And the one from that is specific in Climate Adapt portal for some hazards, it's usually basing on Copernicus data, but it's more user friendly than Copernicus data. And you can see here a very nice presentation, let's say for the river flood index, the historical period, and projections, all presented with these box plots that give you also the information about the uncertainty. So the range of the change, not only the medium value of the change, but the whole range that can happen. Again, according to climate scenarios and for various time horizons. So this, I think this is a very good presentation of data, or very, you get really a lot of information for you from this kind of data. And as I said, Copernicus database, this is this base, CDS. You have a lot of sources here. It's this is always the description of the indicators, but then you need some additional work to get this data out of it. Also here, this one is for some cities again. So you can take a look of the whole Copernicus database. And as I said, we can also help you with getting this data for your area or for your region, maybe even for your city, if you will need some help also in downloading or assessing the data from this like Copernicus database that is not so user friendly than this one, where you can just read the data for your region. So I think I will stop with this presentation, and of course thank you for your attention, and you are welcome to ask something about the presentation. I can explain something again, or Nina can explain something about the tool that you will be using in your risk and vulnerability assessment.